Exercise 2, SolidWorks 2016. This exercise has to do with Revolve features. We're also going to take a look at the rib feature, some sketching techniques and dimensioning, like dimensioning angles, and a little bit more mirroring, and how to build a part like what you see up there. So let's begin. Start with a new part file. And start on the front plane. And if you recall, you could actually grab these files off of the Vertanu 1 webpage under Instructional Manuals, SolidWorks Basics. And once it comes up, again, you could download this file if you like, the PDF, or else just turn to page 30. 30 goes through some of the techniques that you're going to learn today. Two of the main ingredients for a Revolve feature are a profile and an axis of revolution, which could be an edge, a center line, or an actual axis that you could create inside SolidWorks. As you can see here, you saw what our goal was. So since we already started to sketch on the front plane, now we're going to go ahead and select the Centerline tool. Move your pointer above the origin until it infers to it. Click and then connect it to the origin. When it turns orange, click and drag to the left about 5-6 inches in length, and click again. And now you could hit escape on your keyboard. So you should have a vertical line of maybe 2-3 inches in height. It doesn't really matter. And then the horizontal. Now the vertical line we're going to use for our axis of revolution. The horizontal line is going to be used for mirroring the geometry that we're going to create. So in the manual, as I had brought it up earlier, you can see there's a cross-section of the profile right there. We are going to draw what you see here up on the screen, this profile. We're going to draw 1/2 of the profile on top of the center line, then mirror it below. Then we're going to revolve 360 degrees around the axis of revolution. You'll notice there's some dimensions that have diameters in them, and they're dimensioning to nothing on the right hand side. That's a little trick I'm going to show you. And so let's begin. Find the line tool, glide up just short of the vertical center line, so I'm just a little to the left. I'm going to click and drag up a line about 1 inch in length. Make sure it's vertical. Click again. Drag across, make sure it's horizontal. The way you can tell if it's horizontal or vertical are the little yellow boxes. If you see a horizontal line, that means horizontal. If you see a vertical line, that means vertical. So this one needs to be about 0.4, so less than 1/2 of an inch. So like 0.375, whatever you get, it's good. Click. Now we're going to draw a little angle in here because there's a taper on that center. And so just draw this out about 1 inch in length. Don't let it contact the horizontal center line. Just glide up above it like I have it. Click again. Now move your pointer to the left about 1 inch. Make sure it's horizontal. Click. Drop about 1.25 inch length line approximately. Click. A short 1/4 inch line is fine. Click, and now finally draw straight down vertically and connect to the horizontal center line. Go ahead and hit escape on the keyboard. Now what we're going to do next is we're going to mirror this across. So in Lab 1B, I went through some of the mirroring techniques just briefly. We're going to go through it in more detail right now. To mirror this across, there's a couple ways. There's a quick way, and I'm going to show you the quick way first. And there's a slower way. You could just make sure you hit escape a couple times. I'll zoom up here a little bit. I'm just scrolling with my mouse button. Now my middle mouse button. Now I'm going to just up here, I don't have any tools selected. I just click and I drag a fence to surround the geometry I want to mirror over. Notice that the center line was outside of the box just slightly, so thus it wasn't part of the selection when I dragged from left to right. Now if you drag from right to left, it's going to select anything that's contacting your fence. So just be aware of that. That's typical of some CAD systems out there. Okay, notice that these are all selected. If you wanted, if you're unable to get these for some reason, remember you could hold Control and select each one individually, but I'm showing you the fast way here, so we're not holding Control. Now, on the left-hand side here, one more thing we need to do. Actually, we just don't even have to go to the left-hand side. Just hold Control and select the horizontal center line. Now that that's selected, notice the vertical center line is not part of our selection. That's very important. It cannot be part of our selection or else it'll throw us off. With those things selected, we just simply go up to the Mirror Entities button up here and click, and it will mirror over our geometry. There's a couple ways you could do that, by the way. If I hit Escape just to show you, you're able to do this. I'm going to hit Undo just to show you this. I'm going to hit Escape. You could go this route. This is a slower route, but it might be easier for some of you just learning the software. Over here, it asks for the entities to mirror. So you could either select each one. Notice whenever there's a blue box on the left, you don't have to hold Control down. And you can select each entity that you want to mirror. Now there's the Mirror About line box. You have to click in that box to turn it to the shade of blue, and then select the horizontal center line that you want to mirror across. You'll see a preview in yellow. Go ahead and hit the green check mark. So there's another method of actually creating using the mirror tool. There's actually a couple others too, but for right now I think that's enough. Okay, now we need to add the dimensions that we saw earlier. Go to the Smart Dimension tool. Now here's a little trick. If you were dimensioning from object line to another object line, you won't get this to work. It only works when you're dimensioning to a center line. And so we could just select this object line here, this vertical line, release it, then click on the vertical center line. Now here's the trick. Currently, if you're on the left-hand side with the pointer, you'll get just a dimension between the two. But don't click, just move the pointer to the right of the center line, and it gives you double that. It's essentially predefining what's to be a diameter, because this is going to be Revolve. So it's kind of a neat little trick there, and it's nice because you could use these dimensions as diameter dimensions versus radius dimensions for your drawing later on. But let's go ahead and just click on the right side of the center line. Not actually on the center line, just where my pointer is. Click, and this needs to be 0.75 and hit enter. So remember that. It only works with center lines. It will not work with object line to object line. It'll work from object line to center line, but can't have two objects. Okay, the next dimension. Just click right near the middle of this line here, and you'll get what is a 90-degree angle. That's because the last selection was still in a mode for the vertical center line. So if you hit Escape one time on your keyboard, it will remove that one vertical center line and thus giving you just a width dimension. So just in between here, click to drop it, and that needs to be 0.4. The next dimension is an angle dimension. Angle dimensions are pretty easy, but it comes up in class quite a bit. So what you do for an angle dimension is you select the line, not the points on the line, not the end points, not the midpoint, the actual line itself. Click, and now select another line. Like in this case, we could select the object line. This is fine because once you select it, move your pointer between the two lines and you'll get your angle dimension. When it's in there, just click and type in 18 for 18 degrees. Hit the green check. The next dimension, I'm going to do something a bit different. Dimension to the actual vertex or point. See that orange dot? Click on that. And now select the vertical center line. Now remember, in this case, we want a diameter dimension. Move it to the right of the center line to get the diameter dimension. Click to drop it. That needs to be 2 inches. Now, what we could do here is, since it's just 2 inches, we want to see a diameter symbol. While the dimension is still selected over to the left, you have the ability to do a bunch of neat things. The only thing we're really looking for right now, though, is the diameter symbol. Click on it, and it will put the diameter symbol in front of the dimension. Let's try it with the 0.75. Go ahead and one click on the 0.75. Actually hit escape. It's going into an edit mode. Hit escape a couple times actually. Now click on it one time. Just double click on it and then hit the green check mark if you're having difficulty with that. And over on the left, you'll see the diameter symbol. Click on it, and there you go. So now our dimensions are reading as diameters. Okay, the next dimension. Go to Smart Dimension, and dimension between these two lines, this object line to the one underneath it. Move it out here away from any geometry. Click to drop it, and that's going to be 1/4 of an inch, so 0.25. Go ahead and click on the top of this line away from the center point. Drag it up and click 0.25. Now go ahead and select this line right about where my pointer is. Click, drag it out. That's going to be 2 inches. And hit escape. Now you'll notice this geometry is blue. A number of students that I've taught over the years seem to not see this last dimension that's in the actual manual. Again, if you're not sure what is left over and you see it's blue, it means it's underdefined. As I always try and teach, try and make sure it's fully defined before you go into production. So you could just grab this after you hit escape, just drag it. And you can see it's missing the 5-inch dimension, which is the overall diameter of the wheel. So go to the Smart Dimension tool, and I already had that pre-selected because I clicked on it earlier. Now I could just click on the center line, and don't forget the trick. Move it to the opposite side, or in this case the right side of the center line. Click to drop it, type in 5, hit enter, and then to add the diameter, which you don't have to do, by the way. I'm only doing this because it saves time later on when you go into the detailing mode. When you want to make a drawing of this, the person doesn't have to add these in later. It's just taking a quick second to do this. And then I'm just laying them out so they look halfway decent. And I'm ready to revolve now. Now to revolve this, again, there's a couple ways you could do it. But what you really need to do is you need to select what it's going to revolve around. In this case, we want it to revolve around the vertical center line. So after you hit escape a couple times, you could go ahead, you're safe to click on the vertical center line, pre-selecting it. Now you don't have to pre-select it, by the way. You could do this later on, but it's actually quite easy if you do it this way. It just automatically revolves it. So now we go to the Features tab and find Revolve Boss Base. It'll immediately move you to an isometric view, and you can see the preview. And looks good. Be aware over on the left, there's really nothing we want to change, but let's say you wanted it to be less than 360 degrees. As you remove this, you'll see an opening forms. But go ahead and make sure it's 360, so it's a full round. And then click off of it. Alright, now that we have that, let's go ahead and take a look at the filleting tools again. Click on the Fillet tool, and we want to keep it at 0.1. SolidWorks enables you to select faces and edges to put fillets on. This was discussed in exercise 1, but here's a little more detail. On this face, it's actually a good face to select because both edges on either side need to be filleted, so go ahead and select those. You could do the same on the bottom if you rotate it, or you could select the edges individually, which takes a little longer. Go ahead and hit the green check mark. Now let's go ahead and put a larger fillet on. Go to the Fillet tool and set the parameters to a 1/2 inch. Select this edge and rotate around and select this edge on the opposite side. Hit the green check mark when you're ready. And now let's say we decided, you know, these fillets, these 0.1, we want them over there too. There's a couple things you could do. The little trick is you could actually right click on the fillet in the feature tree and edit that fillet feature. So edit feature, and select the edges you'd like to include with that 0.1. You do have the ability to go with multiple radius fillets, by the way. We'll cover that in more advanced lessons. But see, now I have the fillets there, and I still have my 1/2 inch radius. If any of these you ever want to change, you just click on them, and if you rotate, you can actually see the dimension, and you're able to change it if you like. Alright, now what I want to show you is the rib feature. We want to put 4 ribs on here, like spokes. Rib feature is a very nice tool. You just select a face where the ribs would start from. Okay, and beware, sometimes the face is below, or the start of the ribs might be below the faces that you want. In this case, it works out just fine for us, but beware, you might have to offset a plane from time to time, which will be covered in exercise 3. But in this case, we select this face and start a sketch. Go ahead and hit your space bar and go to the top view orientation. You can either select this face or you could go to top. Now take the line tool and infer to the origin in between this little segment here. Be careful not to extend these lines as you draw them too far beyond the boundaries of the actual surfaces. You might get an error if you do that. So I'm just drawing short little stubby lines, and you can see right there they're just floating out there right now. They have to be floating. They can't be on the base surface where they're going to stop. Okay, they have to be floating above, and then they extrude down. So now you go to features, or they could extrude to the right or left. They can't, though, extrude from the bottom up. Go to the rib tool on the features tab, rib. You'll see a preview of the rib, and we could set it to perhaps 0.125, make it a little thicker. Also, draft is commonly used on plastic parts or cast parts, so click on draft, and let's add at least like 8 degrees of draft. You could just type it in, or you could bump this up. Make sure draft outward is depressed, or the checkbox is on there, otherwise it will draft inward to a very, very thin wall if you let it. Go ahead and hit the green check mark, and now you can actually see the ribs. Let's mirror those over. Now, sometimes if you try and put the fillets on first and mirror it across, it doesn't always work really well. So I'm going to go ahead and mirror the rib and then just fillet both sides. So I'm going to go to the fillet tool, and 0.1 for the radius of the fillet is a good size. We could just select this face here, this one, and that one. Oops. Actually, I meant to mirror first. I got ahead of myself there. So let me cancel that. To mirror this, because we've designed it in such a way that the origin was in the center and we mirrored across the sketch, now we want to mirror feature. Now be aware there's mirrored sketches and there's mirrored features. Mirrored features are the 3-dimensional objects that you see on the screen. The mirror sketch is embedded in the sketch tab. That's only for lines, circles, arcs, not for solids. So we're using a different mirror feature in this case. Now we have to figure out something to mirror it across. If you have a face that's centered somewhere, you could select a face of the model. But in this case, we have a top plane. If I click on the top plane, you'll see because we modeled it this way, it's dead center. Sometimes you could offset planes or create them too to mirror across if you don't have them readily available. But when you're working with symmetric objects, as I said before, if you could center things, it makes your life a whole lot easier, especially because you have these planes in the middle. Let's go to the mirror tool. Okay, and this is the feature mirror, as I said before. So you have features, faces, or bodies to mirror. We get into the bodies to mirror in the more advanced classes. Right now, just features to mirror. Go ahead and select one of the side faces of a rib, and you'll see a preview. Now, if you ever have a mirror feature fail to mirror across, you get an error message, try selecting geometry pattern. It does a little bit different behind the scenes and things, and sometimes it will work, sometimes it won't. Sometimes you have to flip it back and forth. But go ahead and hit the green check mark, and now it should have mirrored our ribs to the underside. Now let's go to the fillet tool and select those faces. And again, faces in this case are very useful for putting in our fillets because it's just wrapping around everything. All right. Now you saw in the video, the first one I showed you, that this fillet the color was changed. If you want to do that, remember from exercise 1, you just click on the surface you're interested in changing the color of. Go to the appearances. You could apply just that individual face or the entire fillet or the entire part or body. Go with the fillet. That goes all the way around there. And I keep going with the car, the painted car, and I like the blue, and hit apply. Now if you want, you can actually select the body and select whatever you'd like. Go to the part, click on this little sphere, and let's try plastics. And if we go to clear plastics, you'll find a selection of clear plastics, polycarbonates, acrylics, polypropylene, low density, a number of them. I actually really like the glass effects. They're just marvelous in here. So if you click on the little arrow next to glass, go to thick gloss, and clear thick glass just really gives it a great appearance when you render it. So hit the green check mark, and now go to the little television, go to your perspective, and let's rotate it a little bit, get it in a nice position. And from here you could now go to the render tools and integrated preview. And again, this isn't necessary for anyone to do, but my students, I suggest this so that they could put together a portfolio of their work, and it looks a lot more impressive to see photorealistically rendered images than just the opaque images that you get off of the typical screen. Although sometimes I've suggested to students put both in, because then it doesn't look like a real part actually. Because sometimes people might look at it and think, oh, that someone just took a photograph, those who aren't well versed in photorealistic rendering. But as you can see here, the longer you let it run, the clearer it's going to get. And you could just let it run until you get to a point where you like how it looks. I'm going to let it run for another minute here, and then just do the print screen, or actually if you have multiple screens, hold Alt and hit print screen, or from your Word document, as I showed in exercise 1 how to create the portfolio near the end there. You could get some good ideas on how to do that. But as you can see here, the glass effects are just marvelous, the refraction and other effects that you get off of this. It's just amazing. And that pretty much concludes this particular exercise 2. At this point, you just go to File and do Save As, or Save, and save it as capital E2 for exercise 2 for your portfolio. And thus we covered revolve features, rib features, mirror, and a little bit more advanced filleting, and then a little bit more advanced photorealistic rendering. If you wish to watch after here, you could stop and do the labs and the manual on your own, or you could watch as I go through them on the screen here. Okay, here we are, the labs. We have on page 33, you can see one's a bolt. I don't do the threads anymore, though there is a nice thread tool in the latest version of SolidWorks. I'm not going to do that just yet. We'll go into that another day. But here you can see there's a bolt, and it has a 1-inch head, and the shaft is 1.7, and the overall bolt height is 2 inches. So let's see how we would do something like this. Now also be aware there's the core pin, and then there's a quiz 1 to challenge yourself with. But let's go ahead and do the core pin here. I'm going to go to File, New, Part. select the front plane and start a sketch. Take the line tool and draw out a short little line. The shaft of the bolt is only a 1/2 inch in diameter, so it's going to be less than a 1/2 inch, so 0.2, 0.25-ish. And then this is 1.7 in length, so I'm 1.7, try and get close to it. Click, drag off a short little top there, and you figure 0.25 and another 0.25 gives you a 1/2 inch, which overall diameter would be 1 inch. So stick with a 1/2 inch, or in this case, I'm only going 1/4 inch approximately. And then this is a short little 0.1 height. Again, I'm just getting close, not that I'm. Now I just go straight across. I'm going to show you a little trick using the dome feature, which is really neat. Typically, in most CAD systems, you would use an arc tool, and even in SolidWorks, you could draw the arc in if you wanted to with the sketch tools. But I'm going to have a little more fun with this using the dome feature, which is a nice tool SolidWorks has. So I'm going to go to the Smart Dimensions, and notice here, if I wanted to try and get a diameter, I can't get it. If you recall in the exercise 2, you need a center line. So when it's two object lines, you're not going to get it. But in this case, that's fine. I'm just going to go with 0.25 because I know the overall diameter is 0.5, so this is half of that. Now I'm going to go ahead and click on this to this, and this would be 0.5. The length of the shaft is 1.75. And then I'm going to hit escape. And you can see it looks like it tied itself in a little knot there. If you hit escape a couple times, just grab this blue line and drag it up above that line there. It's really easy to get out of those things most of the time. Sometimes it's a challenge. That's when you might want to hit undo. Okay, now let's put a dimension in that little section there, 0.1. I'm leaving an area open because I want to show what's called the dome feature, and that's in the 3D features. So with this being the way it is, I'm going to go to Features, Revolve Boss Base. Now remember in exercise 2, I actually pre-selected a center line. In this case, I don't have a center line, but you're welcome to use the actual edge of a part. So I just selected that edge, and we can see it revolves 360 degrees around it. Hit the green check mark. Now let's use the chamfer to shave off this bottom edge. Underneath Fillet, select the little arrow and go to Chamfer, and it's set to 0.03 at 45 degrees. You could go ahead and select the edge and hit apply. Now the dome feature. The dome feature enables you to select a face and go to Insert, Features, Dome. You could see immediately a dome is forming, and you can just grab this little bar and drag it out. You can make it look like it's a golf ball on a tee, but we're just looking for an additional 0.2 in height. Be aware there's an elliptical dome as well, which follows tangency to the outer faces of the cylinder that it's attached to. We don't need that in this case, so just turn off elliptical dome if you turn it on. Hit the green check mark. Now here is where students have difficulty putting in the little cutout for the screwdriver head. It's really quite easy actually, but it's difficult. You're trying to train your mind to think in 3D. What I recommend is select the front plane and start a sketch. The front plane runs through the center, and hit your spacebar and go to the front view orientation. And actually you end up drawing the cutout as you see it in the image. So in this case, the base of the cutout is 0.15 from the underside of the head of the bolt. And then it's 30 degrees symmetric on both sides. I know the drawing isn't the best, so bear with me. And we're going to put that in there. So this is where we could use our mirror tool. Notice for the bolt, I did not mirror it. The bolt didn't need to. The Revolve took care of that. Now I'm going to go to the Centerline tool, and at the origin, lock in with an orange dot, drag up a vertical center line, and hit escape. Just have it poke out above the actual bolt head. Now take the line tool, and on this edge, you could go ahead and click on one side and drag it at an angle, and then connect this horizontal line to the center there. Hit escape. Now, this is where you're quizzed on how to use the mirror tool. This one, the mirror sketch tool, not the mirror feature, because mirror feature is for 3D features. We're in a sketch. So you could go over here to mirror entities. Notice I'm in the sketch toolbar. Entities to mirror, I'll select these two blue lines. Click in the mirror about box on the left to turn it blue. Select the center line to mirror it across. Hit the green check. Now we can put the dimensions in. Go to Smart Dimension, click on this bottom line, and the width of that, according to our print, if you look here, is 0.1. Now, dimension between both angled lines, click and make it 30. Finally, hit escape and drag this line up above the bottom of the head of the bolt, because we need to add a smart dimension to the bottom edge of the bolt head. Click over to the right, 0.15, hit enter. Now there's a couple things you could do here. You could close off the top of that cutout, or you could leave it open. Don't always leave them open. They're not always going to work the way you expect, but in this case it will work just fine. Watch what we do here. We go to Features and Extruded Cut. Be very careful. Don't select Extruded Boss Base. That's to add material. Extruded Cut is to remove material. Select that. Now you can't see a whole lot. You see some arrows. There's an arrow pointing in. There's an arrow pointing for direction. The arrow pointing in means that it's going to cut everything on the inside. If you flip the arrowhead, that means it's going to cut everything on the outside. We don't want that, because if we do, and actually if you rotate this, hit the green check mark, actually we're getting a little rebuild error because this needs to be extended a bit further. So I was hoping that it was actually going to allow us to cut that. Let me just, yeah, it's not liking that. Oh, wait, hold on a second. We want through all both. Okay. Make sure you select through all both so it goes both sides. And now you can see the arrow is pointing in means it's going to cut everything on the inside. Just in the event you accidentally selected the wrong side, watch what happens. It leaves the sliver inside there. But remember, that's pretty easy to fix. You can either hit undo, but the easiest thing is just to right click on the cut extrude feature, edit the feature, make sure the arrow is pointing in, which it was to begin with. So hit the green check, and there's the cutout. And go ahead and save that as L2. The IMT 103-2 is optional for your, if you want to go ahead and do that using the Revolve feature. Go ahead. The Quiz 1. I'm going to go through Quiz 1. And you can see it's a 6 by 3 inch rectangle extruded upwards. Has 4 holes in it. Actually 5 if you include the center hole. That goes through. And let's do Quiz 1 now. I'm going to start a new part file. I'm going to draw this on the top plane because the way it's laying or resting, it's a little easier for students to understand. So in this case, the top plane works really well. Start a sketch and use the center rectangle tool since it's symmetric. Dimension it with the Smart Dimension tool at 6 by 3. Draw a center line. Go to the center line tool, and from the center, draw a horizontal and vertical center line. Take the circle tool and float it over here on the left Draw it out. Do not contact the edges. Stay away. Don't do this. That's going to make a tangent relationship. It's going to get locked in. What you have to do, you can delete the relationship if that happens, or just delete the circle and start over again. It only takes a second. Click. Now we're going to go ahead and put in those circles. They're a 1/2 inch in diameter, and they're located 3/4 of an inch off the edges. So 0.5 for the diameter, and I'm going to dimension it to this edge at 0.75. Then I'll dimension the circle to this top edge at 0.75. Now we can mirror this across. I'm going to hit escape a couple times. I'm going to control select the circle along with the vertical center line. By doing that, I'm selecting the center line to mirror across, and then the circle is the object. So I go to mirror entities, it goes right across. Try that again. You could control select the two circles now, and holding control select the horizontal center line. Hit the mirror entities tool, and there you go. Now you could go to features and extrude this. According to the print, it needs to be 1 inch thick. Hit the green check. You're welcome to put the fillets in now if you want, or leave them for last. In this case, 0.25 is the typical. TYP, whenever you see TYP, it means typical on my drawings. Okay, so we go 0.25 and select all 4 corners. If you do this out of order, putting the chamfer in first, you'll see that it will come out incorrect. Putting the fillets in first on this case is very important. Now you could go to the chamfer. Let's see what the chamfer is. The chamfer is called out at 0.125 by 45 degrees. It goes all the way around. So select the little arrow underneath fillet, go to chamfer, 0.125 at 45, and select this edge. Notice how it smooths around there. If you did it incorrectly, you might, if you did it out of order, fillet after the chamfer. This is what it looks like. In this case, it didn't follow around. And if you try and add additional chamfers, you'll get something that looks maybe a little unusual. In this case, the fillets are already there. It fixed it all right. But typically, you want the fillet to come before the chamfer. So it goes all the way around. It's just less selecting. And it might come out incorrect, too, if you do it differently. Okay, notice I didn't draw the big hole in the center. That's fine. Leave it for last because you have to cut through anyway. Select this face, start a sketch, and then hit your space bar. With that top face selected, I want to show you another tool that's very useful. It's the normal to. In this case, we could just technically select the top view orientation, but normal to enables you to select a face. Remember, faces could go at any angle in any position, and it will go normal to. So it's a very important tool to remember. Normal to is very useful. In this case, not as necessary, but still nice to know. Okay, select the circle tool, and since we drew everything at the origin, it makes it very easy to locate. Click and drag out a circle. Drag this out. This is going to be 2.25 for the diameter, and extrude it. Notice I'm not drawing the hole in it. Now, the height is specified as 0.75. Hit the green check. Now you could drill the hole. Select this face, start a sketch, take the circle, and since it's centered, draw the hole. And again, there's a dozen ways to do this. You could have done it any way you wanted. This is 1.25 for the diameter. I'll just verify that on the print. 1.25, and it's through. So we go features, extrude cut, through all. Last but not least, there's a fillet that belongs on there. It's 0.25. Go ahead and select that edge and hit apply. And that completes Q1. Go ahead and save it as Q1 for quiz 1. And this concludes exercise 2.